In this lesson, we're going to take some time and we're just going to define some of the terminology that comes into play throughout our motion unit. So when we are talking about things, we know that we're all speaking the same language, because that's important as we're learning to make sure we all know exactly what is being stated throughout the process. So first off, position. We've already defined position before, but I did want to make sure that we took a moment and just kind of defined it again. So remember, a position is where I am in space relative to some reference point. So then that means I'm going to have some sort of a scaling, some sort of a number line if you wish, and I'm going to have some defined reference point or some defined zero. And then I'm going to say, okay, everything that goes to one side of that is going to be a positive position, and everything that goes to the other side of that is going to be a negative position, just so I'm able to have some sort of an understanding of where I am in space. I have a zero, and then I have a positive side, and then I have a negative side. So I can get some sort of a, here's where I am. Okay, now I'm going to take that and I'm going to add my numbers here just to make sure that we're all on the same page. And we're only going to talk about horizontal motion at this point. So one-dimensional horizontal motion. Later on, we'll talk about vertical motion, one-dimensional, and then we'll talk about two-dimensional, but that's later, right? We don't have to worry about that right now. That comes later on. So when I'm looking at my number line here, my positional axis, and I say to you, okay, I'm looking at the smiley, I'm looking at the lightning bolt, what is their position? Well, hopefully you looked here and you were able to very quickly identify that the position of the smiley is positive 4 meters and the position of the lightning bolt is negative 7 meters. Remember, it's important to include that positive or negative side of your position. That way we know exactly where something is. Okay. So then once we have some sort of an idea of what a position is in and of itself, we can move on to this idea of how position changes or changing position. And remember, we looked at this before when we did our first lab, and we were looking at how position was changing over time. But let's just look at how position changes. So if I look at this walking guy here, walking dude or dudette, walking along here, I can see that their position changes from some start to some end. And I could determine what that change in position is by taking that ending position minus that starting position. So in this case, 6 minus 0, which would equal 6. So the change in position in this case would be 6, and I could use that information, etc., etc., etc. But what if I throw in a middle point here, and I notice that this walking person actually went to a position of -3 first and then went to a position of +6. Well, what is their change in position now? And what this does is it brings into play this place where we recognize as physicists that we need to be able to identify the difference between those things. If the middle point is doing something, I want to know, or sometimes it doesn't matter. I only want to know what happened at the start and what happened at the end. But it does introduce new terminology into what we have going on. So the first piece is this idea of distance. And distance is a length measurement of the actual path traveled, okay? So it depends on where did I go all the way through the path. Displacement is a length measurement between where the object started and where the object ended, regardless of the actual path traveled. So with distance, the direction of travel doesn't matter, right? I'm looking, okay, how far did it go? 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 All the way through the whole idea. Versus displacement is like, okay, where did it start? Where did it end? And its direction of travel throughout that process is very, very important. Now, let's take a look, right? If I were to look here, I would say, well, it started at 0, it ended at 6. The path looks like it's only that one way. So the distance traveled, the change in position for distance is 6 meters. The displacement, ending point, starting point, also +6 meters. That should say +6 meters, okay? Because we have to take into account directionality with displacement as well. And then if I add this back in then, now all of a sudden I have to think about, okay, well, what's going on here for the path to figure out what my distance is? Well, I know I'm going to travel 3 meters in the negative direction to start off first. Then I'm going to travel 9 meters in the positive direction. So when I put those things together and I think about how far this object has traveled, it will have traveled 12 meters. If I, however, then go and say, well, what about displacement? Well, displacement only really cares about where I started and where I ended. Even though I went 3 in the negative direction and then 9 in the positive direction, really what I did was I went 6 in the positive direction from start to end. And that's all displacement really cares about throughout the whole process. This whole idea of distance and displacement brings into account another term, this idea of directionality, or which way something is going. So remember that I have my line here with negative positions and positive positions. So it's important then to be able to identify not only where an object starts positively or negatively, but also which way it's going. Is it going in the negative direction? Is it going in the positive direction? Well, when I look here, I can see my starting person is going in the negative direction. It's becoming more negative as time goes on. That's the way it's moving. My ending person is going in the positive direction. It's becoming more positive as time goes on. Where it starts to get a little bit confusing is what's going on with the middle person. Well, you'll notice that the middle person's change in position is going to be positive. It's going to go from -3 to +6. So it's going to have a positive 9 meter change in position, which means it's moving in the positive direction. These are pieces that come into play as we move forward, and you'll have a chance to practice these as time goes on. All right, next piece. We've already kind of talked about this idea of time, and when we bring time in, we start to add in additional components to what we have going on. Okay, so let's kind of take this for a minute and let's put this back on a position versus time graph, which is something that we've already looked at a couple of times and we have some familiarity with. So my position versus time graph, I know I'm going from 0 to 6. Okay, I'm only looking at those 2 points at this time. I'm going from 0 to 6. And I can bring out my motion equation that goes along with that we had talked about already. So then remember each of these things, right? My position is where an object is at a specific time within this equation. My speed is how quickly my object moved, which we have another definition for that, and we'll put it into play in a second. The time is the amount of time has passed between start and end, and the starting position is where the object started. All of these are things that we've already defined, but it's important to have some sort of an understanding of what they are as we move through. Okay, so our actual definition of speed is the rate at which position of an object changes over time. But we just talked about how there's 2 different ways an object changes its position over time. We talked about how it can change in a way where it changes and it creates a distance, and we talked about how it can change in a way where it's a displacement, where the distance is when the direction of travel is not important, and a displacement is when the direction of travel is very important. So now, all of a sudden, as we keep moving forward through this, we recognize, oh, we need a different term to be able to define which of these things we're talking about, which of these changes in position is important. So speed is the rate at which a position of an object changes over time. It does not take into account the direction of travel, doesn't care which way you're going. Its change in position is the distance one, doesn't care which way you're going. The other one then that we have is a velocity, which is very, very similar to a speed, the rate at which a position of an object changes over time, except that it does take into account the direction of travel. So its change in position that is discussed is a displacement, okay? And sometimes people will say a velocity is a speed in a direction, what we're talking about throughout a process, okay? So quick example, just so we can get an understanding of the difference between these two. Let's say I have my walking person, and we'll say start to end, and my time period is 6 seconds. Just made up a number there. Well, I can figure out that my graph, if I update it, would look something like that. I've included my ending time and my ending position on there. And I can determine my speed as my change in position over time, which is my distance over time, which in this case is it traveled 6 meters, we talked about. It took 6 seconds. So when I divide those out, I would get 1 meter per second. As I then move forward with that, my velocity would be my change in position over time, which is my displacement over time, which is positive 6 meters over 6 seconds. So then my answer would be positive 1 meter per second. Notice that I included that directionality within the motion to make sure that I knew exactly which direction it was moving within that velocity. Again, these are pieces that we will practice more and more. This is just kind of trying to give us an understanding of what these terms mean as we use them within class. All right, quick summary. Position is where I am in space relative to some reference point. Distance, length measurement of the actual path traveled dependent upon the path taken. Direction of travel is not important. Displacement, length between where the object started and where the object ended. Regardless of the actual path traveled, the direction of travel is important. We care about where it started, where it ended, as it moved through. Speed, the rate at which the position of an object changes over time, does not take into account the direction of travel because its change in position that it uses is a distance, and a velocity, the rate at which a position of an object changes over time, does take into account a direction of travel because its change in position is a displacement. So then, as we're moving forward, these terms are ones that will be used in class, and it's important that you understand what it is that's being discussed as these terms are being used. So, looking forward, what does this mean for our equation, right? Because we talked about this a little bit, but how is this going to change? Well, the nice part about this is all it does is it allows us to be more specific with what it is we're looking at in a problem. But that's a lecture for another time.